So first of all, a huge apology for not being able to be there with you present today. It was going to turn into this pretty crazy trip with like 12 hours of travel just to be there for like an hour and a half, and may not have even worked. So it just turned out to be super difficult. So I'm very glad for the AV team, and huge thank you for making this possible so that I could be here today, at least virtually. And I think what I want to get to today, and I'll have some slides in a moment, and hopefully this will just work. I want to talk about the need for a decentralized, permanent, and publicly verifiable record of all human data. And you've been talking about a lot of this stuff already during this whole summit, and I think you've explored a whole bunch of these different topics around how to do specific types of things, a whole huge range of amazing technical solutions for a whole bunch of different kinds of problems. And a lot of these concepts are not new to you. They're going to be things that you think about a lot because you live in 2017, you use a lot of data on the internet and so on. But I want to make the case that it's time that humanity creates an explicit global public record. And so this is something that we're starting to think a lot about at Protocol Labs, the organization that I started to kind of support the growth of projects like IPFS and projects like Filecoin and others. And this kind of thing colors a lot of the work that we do. This is not our main focus per se, but it's one of the things that we tend to think a lot about and tend to focus on. And so I'll explore the space of the problem a little bit, and we'll go into the types of decentralization that we're seeing right now on the web. We'll talk a little bit about how blockchains, and not just blockchains, but the new kind of wave of peer-to-peer helps to create a lot of these publicly verifiable data structures that give us really nice properties. And then we'll talk a little bit about permanence. And I want to kind of highlight this one because it's one of those things that a lot of people don't talk about very often. But so a perhaps small group of people on the internet are increasingly worried about a set of problems around permanence. And related to permanence is the idea of what do you make permanent? So we'll kind of think about a few of these issues. And what I wanted to do, and let me know if this is possible or not possible, but I wanted to just kind of talk about, kind of frame these problems for, say, 15, 20 minutes, and then kind of open to questions, because I find that a lot of these concepts touch on a bunch of really, really complex, difficult issues to think about. And they are, it's best maybe communicated when you engage with like an actual audience and you surface questions and surface tensions with a lot of these ideas. So if hopefully that'll work. Cool, so I'll share my screen. Hopefully this will work out. Let's see. Cool, can you see that? Actually, I'll share my whole screen. Great. So the need for decentralized, permanent, and publicly verifiable data. Let's spend a minute or two kind of reflecting back on the 20th century. So we saw the beginning of the 20th century with the emergence of the telecommunications industry, right? So we had telegrams, and then that's turned into telephones over time, and then we wired up the entire planet with telephone lines, and eventually there was this massive shift towards building a computing infrastructure, and the internet began. And then we spent the better part of the second half of the 20th century just wiring up the whole world with both telephone lines and internet lines. And eventually, the internet lines got so good that a lot of the phone and voice now runs entirely on top of the data lines. So this is a huge packet switch network, right? So we spent a huge fraction of our time and energy, at least in like the technology sectors and so on, building this huge, massive communications infrastructure, all of the physical stuff, and a lot of software that made it all run. But it was this massive undertaking and effort to create all of the wired infrastructure that enabled humanity to suddenly communicate, the speed of light across the planet not only through voice, which we had achieved previously, but now through the use of computers, right? So you could create a piece of software which, in a sense, gives you a whole range of powers, and then use that software with other people around the planet. And this was a massive, massive achievement. Of course, like, you live in 2017, you see it every day, everything you do, or maybe not everything, but a lot of what you do daily happens over the web or the internet in some way or form, and a lot of the software assists your daily life. And so, kind of step back for a second and kind of imagine what life would have been like 100 years ago without the internet, and how your life would have been 100 years ago, or maybe reflect for a moment on the kinds of applications that you rely on daily that you kind of can't really imagine life without, in a sense. Things like the ability to message your family and your loved ones, immediately, and potentially get a response from them, in seconds, minutes, hours. Imagine not being able to contact them for days at a time or weeks, if you were before the telecommunications era at all. Or imagine not being able to use things like email and being able to have this huge infrastructure of communication, and being able to talk about all sorts of issues with tons of people around the planet, pretty much anybody, or anybody connected to the internet, and I'll come back to that in a moment. And then we have the whole suite of larger scale applications that, everything from sharing documents and collaborating on things like that to whole group chats where whole communities can gather and discuss things, to forums where knowledge can be gathered, to things like wikis where over time you can select for really highly valuable and well-edited content, and then whole other ranges of applications, things like ride sharing applications that allow whole communities to create markets that gather resources and allow the switching of those resources. So a whole range of the human experience today in your daily life runs over the internet and over these applications. And the thing to focus on there is that the vast majority of those applications and that all that data that is being generated and gathered through those applications that you use is going to a certain set of data silos, right? So in the first, or I guess the second wave of large and web companies or internet companies realized that data was going to be this incredibly valuable resource, and just established these large applications that kind of locked a lot of that data out. And it's worth reflecting that you don't quite have control over your data, right? There's increasingly kind of realizations about this, certain laws that we are passing to try and figure out whether or not, the data should be hosted in a particular country, and subject to certain requests, like deletion requests and so on. But for the most part, that's a very loose form of control. You don't really have a handle over the stuff that you create. You don't really have a handle over your documents in a way that you could use any kind of software over it. You're kind of locked in to a whole range of products and range of services from one organization. And now this kind of fails catastrophically when that organization has really bad security practices, right? So we've seen a range of problems where there are massive leaks of some sort, or there are just in many cases there have been whole-scale deletions of data, accidental deletions of data, and data loss. So we're in a situation where you don't really control your data. Your data's kind of locked up somewhere, and it is extremely difficult to try and tease it apart and move it somewhere else. And that's the Web 2.0 end world, right? So of course, the whole decentralization and blockchain movement has come, right? So let's now we're starting to see a few potential solutions to these problems, but it's still not, we're only, I will claim that we're scratching the surface. We may be solving some specific deep technical problems, but a whole bunch of social, larger scale, important problems are only getting surfaced now and need to be discussed much more. So, this huge, nervous system that we call the internet, it powers the majority of our applications in our daily life, and the properties of how the data that you use in those settings has direct impact on your capabilities as a human. And so, I kind of like thinking about it in terms of what happens if you lose if you lose access to some of this data, like what happens if you lost all of your email overnight, or what happens if you lose, connectivity to your family or to your colleagues overnight, and you can't regain it, right? And so really kind of think about it that way in terms to like kind of emotionally connect with like the what's at stake here. And there's a whole range of problems here, and we tend to, so in the IPFS project, we tend to think about a few of these things like vast inefficiencies with how data moves, kind of like the web having this bad security model where the content is not encrypted at rest, or encrypted in such a way that only you and the people you share with explicitly can access the data, but instead is to the purview of the service to be able to like look at all the data in the clear. And there are, of course, other things like the fact that links break and it's difficult to find content. There's little to no offline use, so the majority of internet applications require a constant connectivity to the global network, which, from the one part is nice and good because you have these highly interactive applications. From the other part, if you go anywhere that is not a highly connected city, then you're kind of like cut off from the rest of the world for quite a while. And perhaps too that are not so commonplace in our minds daily is the fact that the majority of the people on the planet, we have about like half of the people on the planet with access to the internet, but a huge fraction of that is over really high latencies and really low bandwidth networks. And so you can count on the fact that the majority of the people on the planet, and it's kind of unclear what that majority exactly is, like the percentage, but a huge fraction of the people on the planet do not have access to the same nice, fast internet and the same powerful applications that you do. And so you're extremely lucky in the fact that you do have access to all of that, because it makes you a much more capable and in a sense powerful human that is able to use all these applications. But then it's very critical to kind of turn around and realize that there's lots of people around the planet that don't yet have access to that same computational platform, and it's important to design our structures to be able to get there. There's the IPFS project, in a sense, is a little bit of a critique on the internet architecture itself, or I guess the web architecture itself, on saying that it actually makes it very difficult for people in emerging networks to use the web. So there's a whole bunch of stuff there. And another one is censorship, right? And so we've seen this flare up, periodically in a whole bunch of places where suddenly, almost overnight, some community or some group censors another subgroup. And so this can happen through governments, or it can happen through other kinds of communities, right? And so this is an extremely complicated issue because, of course, some communities should be able to decide what content they share and store and so on. But the tension happens when a larger community censors a smaller community. So something like and maybe like the word larger is not the right one, it's actually power. So it's when a more powerful community censors a less powerful community, or exerts some power in this direction. So the perhaps most quintessential example is the revolution in Egypt, where kind of overnight the internet was censored completely. Nobody could access any of their applications. Nobody could talk to their family and check if they were okay or everything. And so people took to the streets because this whole thing that they've been relying on was kind of shut out overnight. And the fact that governments have that power is perhaps should be called into question, like whether or not you should be able to deprive humanity of access to the internet. At some point, I would argue, is going to reach the same level of importance as whether or not you should be able to deprive humans of water. If you look at our species now, we're very different than we were 1,000 years ago, and we rely on this technology in a massive way. I'm sure that you have you heard the news about Spain and Catalonia and all this kind of stuff, where there was a whole bunch of censorship there too. So it doesn't just happen in certain places where governments are trying to like preserve power in dangers of uprising or whatever, but it also happens in democratic first world countries kind of places, right? So it's a very contentious issue, and it's something that I expect to see more and more every year. So I think we'll probably see more incidences of censorship as people, as governments and those in power realize the fact that the internet creates or rather gives a lot of power to people worldwide in terms of being able to share ideas, being able to organize, and so on. And that is, I expect more censorship, not less, in the future. And so it's a really important moment right now for all of the people working on internet infrastructure to decide whether or not we want something like a censorship-resistant network. So these are all problems that we think a lot about in IPFS and so on. And this is why we think about the need for something that's decentralized, the need of something that is that has some sort of permanence that people can rely on, that won't be susceptible to things like censorship and so on. And of course, there's all the blockchain stuff that has been happening, and I won't rehash all of this here, but I'll just kind of point out the fact that what blockchains enable you to do is create an immutable record globally that people share, like this data structure that allows you to store and share data with each other that is governed with a certain set of rules that allow you to verify that the data is being inserted according to those rules. Meaning that, if you're just a participant in this network, you can check properly that all of these insertions have happened correctly. And it creates a sort of like, in a sense, kind of democratic, it's kind of tricky to use that word, but in a sense, kind of democratic notion of consensus around what is like the correct state of this effectively database, right? So people, the blockchain is not quite a database, but it sort of is. The whole point is that, look, there's just data on the internet that people are collaboratively creating and adding to, and it's kind of permanent. It has some level of permanence, and it's publicly verifiable. And the key point there is that all of the stuff around payments and all the stuff around smart contracts from Ethereum and so on is in a big way possible because of that public verifiability. The ability to check without having to trust any middleman, without having to trust any other agency or central authority, that all of that stuff has been done correctly. And that's a huge, massive win that I think was totally overlooked by the Web 2.0 world. So I kind of see this as like framing, Web 1.0 was just layering pages and content on top of the internet and allowing people to browse those. Web 2.0 was attaching programs and allowing kind of dynamic applications to be built. And Web 3.0 is kind of inverting and saying, let the data structures connect to the data structures and let the programs run with the data structures, and don't think about any of the specific places in which they run. Don't think about the agencies or central authorities that run any of these programs. Make everything completely publicly verifiable so that any participant in the network can verify the whole thing is correct. And so, blockchains give us this kind of stuff. But it's only part of the story, right? Another layer to this is that blockchains enable things like markets, and in the Filecoin project, we think a lot about this. We think about how to displace massive entrenched players that kind of govern a whole portion of the cloud infrastructure and turn that into a much more decentralized market. So things like, the fact that the majority of applications in the world are kind of, or the majority of like large-scale applications are starting to get hosted on a few cloud players is also risky in terms of this centralization of power. And so it would be really valuable to establish infrastructure that is decentralized. And the last thing I'll touch on permanence, and I see that we're kind of 20 minutes in, so I'll touch on this a little bit briefly and then kind of open up for questions. I think is that we don't have a proper concept right now of what it's like to lose massive amounts of data, right? So there were many events in history where we lost huge portions of human knowledge. And it's kind of crazy to think about that today, right? Like we don't really entertain the idea that it would be possible to lose a huge fraction of humanity's memory. This is totally fiction, of course, right? Like we know that there's been so many events in history where whole groups of people went and, there's things like the burning of the Library of Alexandria. There's all sorts of crazy scenarios where some groups will go and like just destroy huge amounts of important, valuable information. So a big question to ask ourselves right now is, what constitutes the record we want to keep publicly for everybody? Of course, we don't want to keep private information there, and that's a very critical thing to distinguish. Like, make sure that like if you're using a blockchain application or any kind of thing that has any notion of decentralization or distribution that's wide and so on, it'll force us to really focus on what is the data that we want to share broadly or make public, and what is the data that we want to encrypt and keep private. But either way, we need to come up with something of a public record. We need a public record that we can attach, say, all of scientific knowledge to, or all history to, or we can start keeping a whole bunch of records here. And of course, this is happening already with huge groups of archivists all over the world that are creating their own collections and their own records and all this kind of stuff. But what I kind of see missing is this like global effort to just identify, just agree upon and identify what we see as the public record of humanity. Like if we were to be able to create, draw a huge circle around all of the data that is part of the public record and distinguish that very clearly, what would that data be? So I think that over the next, something like 2-3 years or something, it would be great to start projects around this specifically, because we now have the technology to do it. And if we establish what that public record is, then we can focus on backing it up very safely. I think something that is worth noting is the majority of the ways in which we store data today, like digital data, are very ephemeral. I mean, they wouldn't last many years if you weren't constantly moving that data to new disks, if you weren't constantly moving into new media and so on. And so we're faced with this like really interesting and crazy problem where the web constantly, websites are disappearing and data is getting lost and so on. And there's efforts like the Internet Archive who are trying to save all of this information and this valuable data as it's rising and falling and so on, and trying to like scramble to try and back up everything as fast as possible, which they're doing a really great job at. But it'd be great to have all of this as part of the architecture of the network. And there's this additional problem of this notion of the digital vellum, which means that a whole bunch of the media that we store information on, sometimes we just forget how to actually read that content, or we lose the ability to create or manufacture the machines that make that readable. And so suddenly you are stuck in a situation where you can't actually access a lot of this public information. So we need a broader strategy around deciding what is the information that we want to put in this public record, how to do it, and how to distribute it. And so this is where a lot of the decentralization tech, so things like IPFS and blockchains and so on, can help. But again, not the whole solution. And then have a notion of how are we going to back this up in a reliable way over time to deal with various levels of threat models. Because otherwise, we may face another huge scale event where we lose huge fractions of our knowledge. And that would be just catastrophic, right? Like think about how much data today is only backed up digitally. And when you realize that digital means just completely ephemeral, and digital means it probably won't last 20 years where it's stored, you have to move it, then that just probably should raise some concerns in the audience. So again, this is we're going to start creating this kind of like call for organizing this kind of like explicit global public record. And this is a very short summary of a few of the issues and things in tension and all that kind of stuff. There's a ton more that goes into this. There's a ton of people working on this already. There's everyone from archivists to librarians to people building technology to people speaking about these issues and so on. And I think we're reaching a moment where we can take a step back, look at the architecture of the internet, and then improve it such that automatically we can decide what information should become part of the public record, and if so, then how to archive it in such a way that we prevent massive loss. Included in that is the range of very important questions around censorship, having people decide what censorship means to them, and when it's okay and when it's not okay. The really hard question around private content: what constitutes private content that other people shouldn't be able to access? What constitutes content that is public and shared and should be and you should be able to include in the public record? This runs into things like the right to be forgotten and so on. And there's a whole host of other issues around how to give access to people worldwide about it, how to work on it, how to fund it, and all that kind of stuff. So with that, and you saying, hey, there's all these problems, we are starting to see some potential solutions in flight, or at least solutions to some of the core problems, it's time to kind of take a step back and look at the larger problem and create some sort of group that works on this kind of stuff. So hopefully this has been interesting and valuable. Just wanted to mention that a few of the things that we work on are kind of thinking about this kind of stuff and laying down infrastructure for being able to make some of these things. But again, this is just a fraction of the solution. There's a ton more stuff and a lot of other communities we need to get involved. All right, thank you. And if there's any time for questions, I realize there may not be that much, but if there's time for questions, I would love to take some.
Thank you so much, Juan, for this inspiring talk, and I guess it sparked some questions. So anyone, there's a few questions, Juan, so. Yep.
Hi Juan, thanks for the talk. There are not really that many large-scale cloud providers that can allow us to store this amount of information. So, I can think of kind of Amazon, Google, Microsoft, and then obviously there's some smaller hosts as well. So isn't there a risk that just by kind of decentralizing and mainly storing this stuff on the cloud, that we're just pushing the problem downstream and to another form of centralization with these kind of three main providers?
And so this is a larger question around how do you decentralize that itself. And so I work on a project called Filecoin, which the explicit goal there is to create a market that, instead of having like this really coarse market where there's three large players that store the majority of the content, and you kind of like are completely locked into those, or rather they give you like full suite of solutions. How do you decentralize the whole process of actually doing data storage in the first place? So think of something like Bitcoin mining, where there are people around the planet with computers that are adding to this. Of course, Bitcoin is kind of centralized now too, right? So there's some aspect of re-centralization in things like Bitcoin. But we think that there are solutions to those kind of problems around prioritizing latency of delivery of content that makes. And pressures like that will encourage the content to be distributed around the world with a lot of different kinds of providers. But again, that's only a fraction of the problem. I would say that getting a totally decentralized storage network is one step towards this, meaning create structures where it's not one or two players controlling all the data, but it's rather the union of hundreds of thousands of players, potentially more. Serving and storing a lot of this data, and create facilities for people to express that and say, hey, I want this data stored by different identities and in different geographical regions and all that kind of stuff, and create programming interfaces to enable that in an easy way, as easy as you send a Bitcoin payment. Think about it this way, or an Ether payment. But again, like even just decentralizing and distributing the storage is one step and one part. The next part is, from there, how do you back it up long term? How do you first identify the public record, distribute it worldwide, and enable fast, quick access to both read to both write and read from that record? And then step two is, how do you back it up in a reliable, solid way that it's not going to be completely ephemeral or subject to massive failure, so that it can last not only decades but centuries, or millennia if we want to be ambitious. It's kind of crazy to think about like clay tablets being able to last 5,000 years, and the majority of the stuff that we store our data on today wouldn't last 100.
Cool, thanks. I'm really excited to follow your progress, and yeah, best of luck with everything. Cheers.
All right, we have one more question.
Thank you very much, and I think you bring up a very critical issue. And I've raised this question before. So as a lawyer and a scientist, I tend to store my critical bits of information on paper, because so long as I can read, I can retrieve that. And electronic media, as you say, is ephemeral. So clay tablets and paper have that advantage. So it might be a combination, but in researching this, because I have become quite concerned about this myself, I think in this digital era, we're in the danger of losing humanity's entire experience for this period, because we're not paying attention. And so I'm also concerned about this as a policy issue. I've recently come across people working with DNA to store information, and that actually the recent results are pretty stunning, that you can store music and retrieve that performance. And as a genomics scientist, I would say that DNA has some advantages because actually you don't need power. Actually, it can survive quite well in normal conditions. So unlike the internet and databases where you need electricity. So what are your comments on DNA as a potential medium? And are there any other media that you would look at?
Yeah, I think there's a whole range of these. I think DNA is a great example of one class of technologies that we can use. The way that I tend to approach this problem is thinking about a certain set of threat models and then a set of operations that you want to be able to do with one kind of level of technology, right? So DNA has the features that, it's tiny, you can compress massive amounts of information, and it is fairly durable, quite durable. And then there's questions around how do you read it back out? So reading it out requires a whole set of machinery that if you have lost those machines or lost the ability to create those machines, then that's difficult, right? So this gets into threat models. We could probably do things like store vast amounts of information in DNA and in a threat model that assumes like we won't face any like massive major catastrophe, or in a case where at least we store all of the information of how to get to read the DNA information in some other medium, right? So you can think of this kind of like a bootstrapping problem, like a recursive bootstrapping problem where maybe DNA is like the most dense, then there's like a less dense thing in like crystals, and there's like a less dense thing in like, again, clay tablets or carved into stone or whatever. And at some point, like you create these like caches. You could create like these massive caches around the world that like have all this information. I think framing it in terms of threat model and what are the properties that you want. There's no single medium that will satisfy all of our needs. For example, again, it's extremely useful to have the entire public record constantly online and be able to read and write from it really quickly. And so it's like this suite of different media, and we need a very well-structured process for how to translate this information and write to it, and then distribute it around the world and safeguard it. That's a whole step that like isn't really there, and it's quite concerning. But I think I think it starts with, let's identify a digital public record that we can all agree on, and we could use things like blockchains and all this tech to identify that and start putting a lot of applications on top of these things and automatically start deciding what is the data that we want in the public record. And so this is like really step one. And once we've done that, then we can move into towards start backing it up across these different mediums.
Thank you, Juan.